You're standing on a scorching, sun-baked African plain. But as you look up, the heat haze breaks, revealing something that defies the landscape entirely: a massive, freezing peak covered in snow. This 3D map shows the extreme elevation of the African continent. Zooming in on Tanzania, you can see how Mount Kilimanjaro towers over the surrounding flatlands. Reaching 5,895 meters high, it claims the title of the Roof of Africa. Most mountains feature a somewhat consistent climate along their slopes. Kilimanjaro operates differently, functioning as a vertical stack of distinct ecological worlds layered directly on top of each other. Every year, thousands of climbers arrive to scale it, unaware they're racing a ticking clock. The pristine snowcap sits in stark contrast to the warm landscape below, and that white crown is rapidly melting. An ice giant sitting directly on the equator defies basic geography. That contradiction makes it a magnet for global explorers and leaves it highly exposed to even slight shifts in global temperature. The journey starts inside a dense rainforest. Looking through this heavy jungle foliage, the distant peak feels like a different planet, separated by miles of thick green canopy. This lower tier operates as a sanctuary. The volume of water cascading off the upper slopes feeds thousands of plant and animal species that could not survive out on the dry savanna. It is a loud, vibrant environment. As these elephants roam the foreground, the towering mountain provides a constant backdrop to the calls of colorful birds and the movements of large wildlife. The entire ecosystem thrives here because the mountain is so massive, it generates its own weather. Its size forces passing clouds to drop their moisture, drenching the lower slopes in rain. Before Kilimanjaro tests physical endurance, it functions as a massive biological engine. It proves a mountain can act as a crucial source of life for the surrounding land. As you climb higher, the environment shifts. The greenery of the rainforest falls away, replaced by freezing valleys of rock and dust. This is the human element of the climb. Thousands of people navigate this harsh volcanic terrain, seeking adventure and pushing past exhaustion. This cross-section charts the impact of altitude. As the elevation line moves up, the temperature plummets, and the available oxygen percentage drops in an inverse slide. Higher in this zone, the body begins to struggle. Fierce winds and thin air turn the hike into a battle against the mountain's raw power. Reaching the summit reveals the mountain's true geological nature. This massive, barren crater sits suspended above the clouds, marking Kilimanjaro's identity as an active volcanic structure. Success on the final approach depends on psychological endurance. As the landscape becomes increasingly hostile and alien, the mental drive to continue becomes the primary obstacle. The reward for the ascent is standing face to face with the white blanket of glacial ice. Seeing this massive, jagged wall of frost isolated above a sea of clouds creates a powerful sense of permanence. That sense of permanence is misleading. The ice that defines the mountain is succumbing to the effects of a warming climate. The decay is visible to the eye. This isolated glacial wall is retreating up the dark volcanic ash, fracturing at its edges and leaving bare rock where deep snow used to rest. This map illustrates the summit's future. Tracking the historical footprint, we see the ice coverage shrinking drastically inward toward zero. If current warming trends hold, climatologists project the ice will vanish completely, leaving a bare summit within our lifetimes. This is more than a change in a tourist view. It is the loss of a critical planetary indicator. The fragile giant is dying in plain sight. Kilimanjaro now issues two distinct challenges. The first is the physical courage required to climb it. The second is the collective courage required to protect its living ecosystem before the Roof of Africa is lost forever.